how we roll it. Some rock, some wind, some 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 wind.
Hello, everybody. I don't know if you noticed, there was a rendering bug in the intro this time. That is a super annoying TypeScript bug in the animation code that has been bugging me forever, and this time I forgot to compensate for it. Anyway, Zig Show Time, episode number 38. Welcome. The topic is not TypeScript bugs, but instead is going to be about the rewrite that Rock has been going through recently. And so let me introduce the guest for today. The guest is Richard Feldman. He is very famous. He has been a speaker at many prestigious conferences, including Software You Can Love. And he's also the creator of the Rock programming language. So let me pull him up on stream. Hi, Richard. How are you?
Hello.
Let me try to say something just to double check the volume.
I'm saying something. Checking the volume.
Okay, you sound good. If you can pull up yourself a little bit more, that would be.
I can turn up the volume. Yes. I can also just be louder. How's that?
Oh, that is perfect, I think. So if anybody in chat
Nice.
has different opinions, do let us know. So, welcome. Is there anything else that you should have said about yourself other than you've been a speaker at prestigious conferences like Software You Can Love?
I don't know. I guess a lot of people before Rock knew me for Elm stuff. I used to do a lot of like Elm programming, doing libraries and like conference talks, and wrote a book about Elm and gave workshops about Elm. And eventually I decided to make Rock because I wanted to make a language that was the things that I liked about Elm, but in a different like domain, different use cases than Elm.
Nice. That's actually a great continuation into what is special about Rock then? Because most people, I think, in the audience will know what Rock is. You've been friends with this community for a while now, but just to have everybody catch up. So, what's interesting about Rock?
Yeah, I always lead with something different depending on the audience. So I think for this audience where everybody's used to using Zig, I think an example I might give is for use case for Rock is something like Ghosty. So Ghosty, terminal, my daily driver terminal now, written in Zig, of course. So let's say that Mitchell decides he wants to add a like a scripting system for Ghosty, and maybe he's already thought about this. I don't know, but let's pretend that he is thinking about it for the first time. The pitch for using Rock as the sort of scripting language for that is that Rock is a language with a built-in type checker. It's a functional style language, but it has increasingly good support for imperative style programming if that's what you prefer to do. It's like a pretty simple language. The idea is that it compiles really fast and that it also can run really fast. So in the context of a plugin, things that might be interesting here are, one, we have a story around being able to get like a type checked boundary between the compiled Rock like plugin and the host. So you can use Rock as sort of like an embedded thing to embed in a larger program, including like compiling it down to a dynamically linked library or something like that. In the rewrite, we're also going to work on like sort of an interpreter mode where the like Ghosty, for example, can just say like, give me a .rock file, ROC is how you spell it. And then it can just like interpret it and run it at runtime. But we can also say like, okay, because we have full type inference and also like type checking, we can say for the author of Ghosty, say, we can just generate bindings to Zig. And so that like Zig can just be like, oh, cool, here are typed bindings that will just work for this Rock plugin, whatever the end user wants to do. Actually, we don't currently have those bindings for Zig, but we have like a sort of generic binding generation system. It's just nobody's like written one of those for Zig yet. But the point is that like the language is designed to make that sort of thing easy. The ecosystem is not fleshed out yet because we're not even at like version 0.1 yet. But yeah, so that's like one example. And then on the complete opposite end of the spectrum, you have like, I just want to build a web server. I just want to build a command line app. And in that case, we have basically like, you can take your Rock program and you can say, okay, I'm going to build this on, we call them platforms, but you might think of them as like a framework. I'm going to build this on a framework or a platform called like Basic CLI is one that we have for command line apps, or Basic Web Server is one for web servers. There's another one for web servers called ENA. Anyway, they all do like different like they have different trade-offs around
Right.
like sort of being good at that domain. And At any rate, the point is that if you do that, then you can compile it all the way down to like a complete statically linked executable. And then in that point, you're using Rock sort of more like a Go competitor. So you can think of it, I guess, in summary as like either a Go competitor or a Lua competitor. But in both cases, you have like a fast compiler that compiles fast, generates fast, like optimized code time because it monomorphizes and uses LLVM for the optimized builds. And what you're writing is sort of a functional style rather than like an object-oriented style.
Makes sense. Makes perfect sense. So yeah, I find personally Rock interesting. Thinking of a talk that I listened to a while ago from Mason Remali, he made a point, and again, he made a point. You were talking earlier about different audiences having different sensibilities. He was making a point to a, let's say, Zig/game dev audience. So like his talk was aimed at like the handmade network kind of people, and where he wanted to make a point that sometimes it is a good idea to take a step back. And while it is true that when you're making a game, you want to be sometimes like indie and minimalistic and just write exactly the things that you need, but there's a value in creating tools that you can use to have other people work on your stuff. So in his case, it was like you have artists, and an artist needs an easy way to try things out. So like these type of tools that have like two phases to them, where on one end it's the highly technical person, and on the other hand is the more creative person. I'm imagining that like Rock is also a natural fit for this kind of use cases.
Could be, yeah. I mean, I guess like anytime we're using like the overhead of a garbage collector, in our case, we actually do automatic reference counting, but same basic idea. Any case where like sort of delegating memory management to some generic system as opposed to managing memory yourself seems like it would be reasonable, and like nobody would notice a performance difference as long as everything else is fast. Like obviously there's like a whole range from like Python to Go of like how fast those things can be. Yeah, anything where you're in that sort of space, we're hoping that like Rock would be like a potentially like viable choice for people. Obviously there is like, a matter of taste and preference. So like, somebody might say, well, I like Go better than Rock anyway, even though it could be used for these things, which is totally fair. But my feeling is that something that is missing is like a nice, simple, functional language that's like builds fast, runs fast, etc. There's a lot of different functional languages out there, but none of them are quite meeting that sweet spot the way that Elm has for me in like the browser for browser-based UIs. But Elm compiles to JavaScript and we're compiling to machine code.
That makes total sense. Okay, so you're working on this project, and I remember meeting you. We met for the first time talking about Handmade. We met at Handmade Seattle, which was organized by Abner Coimbra, who was earlier in chat. Then he said he went to take a shower, so hopefully he will join us before the show is over. But we met there, and at the time, I believe you were of the idea that while in the end, I don't remember if at the time you already had a Zig standard library. Did you?
I think we did, yeah.
Okay, you did. But at the time, you did not feel comfortable with the idea of going the Zig all the way. So you started with Rust, and that was your comfort zone. So, what was your experience getting there, and then from there getting to now we do everything in Zig?
Yeah, it's a great question. So I guess the reason for, maybe I should talk about like the reason for Rust in the beginning, and then why we decided, even after we decided to start using Zig for the standard library, we didn't decide to rewrite the rest of the compiler in Zig, and like why we are now deciding something different, and we are going to rewrite the compiler in Zig. Actually, it's already started. This is only it's like a week ago. But like if you look in the repo now, you can see a lot more Zig than there used to be. So the original reason for Rust was actually pretty simple. It was that my background as a programmer is like when I was in like, I don't know, middle school, like I got started like basic and Visual Basic making games, like a lot of people did, at least back in the 1990s. And then at some point I heard like, hey, if you want to make serious games, everybody uses C++. I was like, oh, I'll learn C++. And for short, I didn't have a great experience. Like I learned it and I was able to build, like I made a little role-playing game in it. And I specifically remember hitting these like memory corruption bugs and just feeling totally lost as to like how to debug them.
Yeah.
Maybe today I would like, if I had started that today, maybe I would have learned about tools like address sanitizer and stuff like that. But back then I not only had no idea about those, but I was like literally learning from physical books. Like the internet was kind of like a new thing. Like not everybody had it. And there weren't nearly as many resources as there are today. So I just felt like, man, this is really hard. I don't really want to do this anymore. And so I kind of ended up just gravitating back towards more like garbage collected languages. And then when I got into industry, I had a conversation with a friend, like when I was in college. I was kind of like, oh, I'm going to go into game dev. And I was talking to her about her experiences like in game dev. She's like, the industry like chews people up and spits them out, right? I was like, huh, what? And so I got sort of scared away for multiple reasons from like going down to the game dev path. I think today I would be less scared of that, but at the time I certainly was. And so I ended up just like getting into web development and like some people, because like that's where a lot of jobs are, and just working exclusively in garbage collected languages for a long time. Fast forward to I've decided I'm going to create Rock, and I'm like, okay, I want the compiler to be really fast. That's really, really important to me. Like really fast feedback loops in this language is like an absolute like foundation level. Got to have it. I also knew from past experience, Evan Shaplicki, who made Elm, like when he had made Elm's compiler a lot faster, he didn't do it by like rewriting the algorithms underlying things, like the same type inference algorithms, the same parsing, like fundamentally, same code generation. The way that he made it a lot faster was by basically going through and doing sort of bog standard performance optimization things. And Elm's compiler was and is written in Haskell. And I remember that some of the tricks that he used to make it faster were he went in and started using like C extensions where he was like writing his own representations of some data structures in C in order to import them into his Haskell compiler in order to make it go faster. And one of my takeaways from that is if you really want to have the fastest compiler possible, it's really, really hard to do that if you are limiting yourself to only like a, compiled language that uses, automatic memory management. We've had this FAQ entry that's also been kind of a day one thing where I've always said, we are never going to self-host Rock. Like Rock is never going to be rewritten in Rock because the goal is that Rock does not have those low-level primitives. Rock does not give you direct control over memory. Like you're trading off that control for the simplicity of a language that's like, if you're in the domain where you're like, yeah, automatic memory management is going to be fine, we can offer you all sorts of conveniences and things to make your life better and easier and help you write your code faster and debug it more easily. But at the cost of we're lowering the performance ceiling on what's possible. And I think for Rock's compiler, we don't want that ceiling lowered. We want it to be as high as possible. So in that moment, I'm looking around. First of all, candidly, like when I first started writing this code base, like I designed the language in 2018, or at least designed it enough that I felt comfortable to start coding it. In like January 2019, I had never heard of Zig. I now know that it existed, but I actually found out about it later that year. Actually, funny story, because I live in Philadelphia, and also for those who are watching, you might know that the Eagles won the Super Bowl last night. So, Philadelphia as a city is there's a lot going on right now. But so we have this local conference called Philly ETE, and because it's like a local conference, I was speaking there, and I walk into the speaker dinner in 2019. And I just walk up to the first person who I see in the speaker dinner, someone I'd never met before. I said, hi, my name's Richard. I'm giving a talk about blah, blah, blah. What's your name? And he said, my name's Andrew. And I said, oh, what are you giving a talk about? He said, oh, I made a programming language called Zig. And I thought, I've never heard of it. Cool. Tell me about it. And we kind of like started going back and forth. I was like, oh, I'm also making a language. And one thing led to another. And like by the end of that conference, like Zig was very much on my radar. But I'd already started at that point. I already had like, not as much as today. Now we have like 350,000 lines of Rust. But back then, I don't remember how many, thousands of lines, but I'd already been spending quite a lot of time writing in Rust. So why did I choose Rust? Well, the main reason was just that Rust had this promise of like, you get the performance ceiling and you don't get the memory corruption errors. Yeah. And so I'm like, cool, I want the performance ceiling, and I'm scared of my past experiences. I have all these scars from like C and C++ development. This seems like the only choice for me, where it's like, I want to not have to deal with those errors anymore because I remember how scary they were and how miserable they were to debug. And that was on like my, couple thousand lines of code role-playing game with no graphics and like, ASCII art. And now I'm talking about doing this for some gigantic compiler. Like, no thanks. I don't want to like go down that road. And so although I didn't really know Rust, I'd like used it a little bit, like kind of a project that really never shipped previously. I was like, yeah, I understand this well enough that I feel comfortable committing to this as like, this is going to get me the performance I want without the negative experiences around, memory corruption bugs that I didn't want. So that was the reason for like starting off with Rust. It was really as simple as that, just wanting those two things. And so when I talked to Andrew about this, I was kind of like, okay, like this seems like an interesting language. I really liked his talk that he gave at that conference, where he sort of outlined his perspective on like, C has a language has a lot going for it. C++ tried to improve on a lot of C's problems and like try to improve it in various ways by adding a lot of complexity. I want to improve on C by subtracting complexity and making it simpler and nicer and more consistent and still like, more productive and capable language. And I was like, that seems cool, but fundamentally it still seems kind of out of reach for me because I'm not one of those people who's able to deal with low level memory management, or so I felt at the time.
Yeah.
And basically, so the way that we ended up with Zig in the standard library was just that at some point we were like, okay, we have these foundational low level primitives. And at first we were actually just hand generating LLVM for all of them, which kind of works fine when you're talking about like arithmetic instructions. But as soon as you get to the part of the standard library where you're like, cool, we want to do small string optimization, where you have like strings that are sufficiently small get stored inline on the stack, as opposed to like needing any heap allocation. That code started to get kind of hairy, and then we're like, cool, now we want like a dictionary that's going to be part of the standard library. Do you want to write a whole dictionary by like hand-generated LLVM, which is basically like worse than hand-generated assembly? It's like less ergonomic than hand-generated assembly.
Yeah.
So we were like, okay, this sucks. Like we need like to use a higher level language for this. Obviously, our first choice naturally was Rust, but we ran into a bunch of toolchain issues with Rust. I don't know if the situation is better today, but at least at the time, we were really struggling to get Rust to consistently output. I think we needed LLVM bitcode because we wanted to import these into LLVM and just kind of merge them into your compiled program so that there was no like missed opportunities for optimization between like the standard library and your compiled rock program. And then also we wanted to generate like WebAssembly code standalone, I think, and that was also a problem. At any rate, we ran into all these problems, and eventually we were like, okay, let's just try C or something like that. And then somebody was like, hey, if we're going to try C, why don't we just try Zig? And I was like, oh yeah, Zig. I remember hearing good things about that language. It seemed like interesting. Like, let's give it a shot. Let's see how it goes. And we had a really good experience with it. So at that point, it was sort of naturally narrowly scoped because we'd already decided we tried Rust for this use case and we had a bad experience. The whole rest of the compiler's in Rust, so we don't have any desire or need to rewrite that. But we have discovered that Zig, just for the standard library, seems like a good fit. Let's try it out. And so we did. So we ended up, I think it ended up being like 10,000 lines of Zig code or something like that out of the 350,000 compiler. So we had a good experience with Zig for that. But as I mentioned, like we didn't really see it as like, oh, let's go rewrite the whole compiler in Zig. One reason is just like, when you have a compiler like a code base that big, it's really hard to justify rewriting it in anything. So we had talked about how I was like, man, I really like, what was it, like the Lexer or the parser, something like that. I think it would be a lot nicer if this were in Zig. And we talked about it's like, yeah, but we already have this one sort of insertion point where we're trying to like compile a big chunk of this like from Zig to LLVM bitcode, and then we have to like incorporate that into our build process. And if we also have to incorporate it into the build process of the compiler again, it's like everything's going to get a lot more complicated. So we're kind of like, yeah, okay, fine. And then also like contributors now need to ramp up on like Zig, even if they're just working on the compiler and not on the standard library, they now need to ramp up on Zig and Rust just because the two are like talking together, and then we have to like keep the data structures in sync on both sides, or like the parse AST is now in Zig, but then like the next stage of the compiler in Rust needs to consume the Zig one. So we have to, keep that like FFI boundary. It just seemed like trying to do an incremental like rewrite of any part of the compiler in Zig was just going to be like really hard to justify. Yeah. However, I mean, we still had a good experience with it, so it was always kind of like in the back of my mind, like, we could do that if the time ever came that there was some justification for it. But I didn't really think it was going to happen because we'd explicitly talked about it and kind of decided not to do it. The thing that changed basically was just that we had this recent like sort of get together of compiler authors, and over the course of the past year, we've had a lot of design changes to the language, like based on things we've learned and like things that we want to do with the language based on how everything's gone so far. And we kind of ended up at this point where it's like, okay, let's go just take an inventory of all the different parts of the compiler that need to change and how they need to change in order to achieve all these design goals. And basically it ended up being like, okay, parser should be rewritten for this reason. Totally unrelatedly, we want to rewrite the next stage, which was called canonicalization at the time, and now we're calling resolving. That also needs to get rewritten for totally unrelated reasons. Also, the like loading logic needs to get rewritten for a totally different reason. Also, and it's just like on and on and on and on. Like every stage of the compiler, except for type checking, there was some reason that we wanted to rewrite it. Type checking was fine, but it was sort of like, okay, at this point, we're basically talking about incrementally doing a rewrite of every single stage of the compiler except for one. And then at the end of the day, we end up with, a Rust code base again, that has been rewritten piecemeal and to get the functionality we want. But of course, at that point, we have sort of all the accumulated cruft that we've had, like all the technical debt, all the usual stuff that happens when you have a code base that, evolves over time, like incrementally. And, this is just normal programming stuff on a big project. And so we kind of had this conversation of like, all right, let's suppose that we are doing a big, rewrite of all these different pieces. What if we, talked about rewriting the whole compiler from scratch? So usually whenever somebody has this conversation, especially if you're saying, let's do a rewrite in another language, the first thing people bring up is like, that's super risky. These projects might fail. They often also introduce regressions, etc. So on the regressions front, fortunately, we've been really, really consistent so far about setting expectations around like, hey, this language is pre.1. We don't even have a version number. We've never had a version number. Stuff's going to change. Stuff's going to break. So, if you're going to depend on Rock, like in production, which actually a couple of people are, we're sort of like buyer beware. Like, you know what you're getting yourself into. There's going to be breaking changes. So I didn't feel that bad about like, well, if we do have some regressions along the way in this rewrite, like everybody knows to expect that sort of thing. So I don't think that's as big of a deal as if we're like, certainly if we were like post 1.0, that would be a really, really, serious thing to have major regressions in terms of like functionality, like not being ported over. Second thing though, is that, and this is something that I didn't really realize until I thought about it in these terms, which is that it is actually, for compilers in particular, it is normal to have a rewrite in another language. In fact, if you don't rewrite your compiler in another language at some point, you're like doing a weird thing, because most languages self-host their compilers. And Java got rewritten in Java, Haskell got rewritten in Haskell, right? Zig got rewritten in Zig, Rust got rewritten in Rust. It's just like, no matter what your language is, it is very normal to rebuild the whole code base from scratch in a different language. And yes, that language typically is the language that you're building, but obviously there's no reason it has to be. Like Java rewrote in Java. So obviously you can rewrite your compiler in Java and end up with a successful compiler. Haskell rewrote in Haskell, Zig rewrote in Zig, Rust rewrote in Rust. So like you can sort of decouple the observation of like successful compilers most often, like way more often than not, rewrite in a different language. You can decouple that from ... and the target language happens to be the language that they were rewritten in, because all of these languages ended up rewriting and having successful compilers, even though they all rewrote to completely different target languages. And yes, there is like an argument about, if you self-host, then you can get more contributors because more contributors are like comfortable with your language. Fair enough, but we're not really specifically worried about that. And also I kind of suspect that because so few languages do this, that there's a little bit of a hidden benefit where like, we can probably get some people who are interested in Zig, but not necessarily interested in Rock, because they're just like, hey, I just like want to work on a compiler or this aspect of a compiler. And that sounds interesting to me. Like, I'm not really into your particular language, but I am into Zig. And so like, this is a good excuse for me to just get involved in like a code base that's in Zig, that's doing a real thing where if I work on this project, actually real people will use it. Which, by the way, we have lots of contributors, so anyone is welcome. Who's listening to this, like if you're interested in that, feel free to hit us up on Rock Zulip if you want to get involved in the compiler. You don't need to be into Rock to contribute to the compiler.
Yeah. That was also my experience with Zig. Back when Zig still had both the C++ Stage 1 compiler and the Zig compiler, every time you wanted to contribute to the compiler, you would have to implement it twice. One time in Zig, one time in C++, which, to be fair, it's a great exercise that teaches you to appreciate what Zig gives you over C++. But that made me not want to contribute to the compiler. Like, I think at the time, I had only contributed to the standard library because there was no way I was ever going to implement anything. Like, already working on a compiler, it's hard if you're like just a random dude and you're not the crazy guy that decided to start working on a compiler. And then if you have to do it also in another language that you're not comfortable with, it's like super hard. So yeah, that's interesting. So let me take a moment to address a couple of things for the show, for the audience. So first of all, hi Lucas, thank you for the $400 donated to the Z Software Foundation. Thank you very much appreciated. For everybody else in chat, I didn't say this in the beginning, partially because I forgot, but partially also strategically, so that Richard could set some context. Now that you know a little bit about what's going on, feel free to ask questions whenever you want. I am reading chat, so whenever you ask a question, if I find an opportune moment, I will relay that to Richard so that we can address your question. So do not expect a big Q&A session at the end. Ask as we go. Maybe tag me to make it clear that the question is for the stream. And so Richard, I have a question for you. So given where we got up until now, which is, did you experience like an issue where maybe you end up with like two different groups of contributors? some that do standard library only, some that do compiler only, or did you have like good cross pollination between Zig and Rust?
That's a great question. I would say we certainly had a lot of cross pollination. I will say that some people would contribute just to the standard library, mostly because I think they were either intimidated by or just not interested in getting into like other compiler stuff. So a common thing that would happen is like, obviously, a good chunk of our standard library is written in Rock. It's just like the lowest level primitives that can't be expressed in Rock are expressed in Zig, because or actual in some cases they are still going directly to LLVM IR. But basically, like a common thing that would happen is somebody would be like, oh, I just like want to add this thing to the standard library. Sometimes you can do that just by writing Rock code, and it's fine. Other times it's like a little bit more of an advanced use case and you need to add a new primitive, and then they would kind of like get into Zig. But if all you wanted to do was to end up with the standard library having some new additions, then there wasn't really any need to get into the rest of the compiler. I actually more often saw it going the other way, where someone would start working on like compilers, or they would show up because they were interested in compiler stuff in general, and then like adding something to the standard library was just kind of a generic way to get into the code base in like without having to completely understand like how the parser, the type checker, or whatever works.
I see. So in the end, it wasn't too bad. But so in the story you got, they were telling previously, so you got up to the point where you were not considering Zig. You did have, for the whole compiler, you did have Zig in the standard library, but then you had a lot of things that you wanted to rewrite. And while you're not interested, you were never interested in self-hosting, understandably, also because not every language is necessarily the best language for this kind of tooling. Like Go, for example, the Go project, when they self-hosted, they lost a bunch of performance by self-hosting. Yep. I think they have improved things over time, but still, obviously, Go is a higher level programming language than C, what they were using originally. So you got up to this point, and so at that point, rewriting in Zig seemed an actual real possibility, right?
Yeah, and not only a real possibility, but I think some other things are relevant to note that have changed about my perspective since that 2019 when I was writing the first like lines of code. So one thing that changed is that I've gotten a much bigger understanding of what a like high performance compiler needs to optimize for in this day and age, at least at the low level sides. There's a lot of algorithmic stuff which like hasn't changed. It's just sort of like, if you do this, the compiler is going to be slower than if you do that. And like there are trade-offs around that. But the other things are sort of like, regardless of which like algorithmic strategy you choose, which has trade-offs with language design and stuff like that, there's just like, how do you represent memory in data? And speaking of Handmade Seattle, I think it was 2021 when Andrew gave his talk about like data-oriented design in compilers. That stuff had sort of like been on my radar at that point. Like I'd been learning about data-oriented design in game dev primarily, and but like it hadn't really like hit home for me, like, okay, what does it look like if you apply all of this to compilers, until I saw that talk. And at the end, I mean, everybody like on the Rock compiler team was talking about that. And just like, hey, we want to have a compiler that goes really fast. Like, why aren't we doing this? And so we started doing it in Rust. And to make a long story short, this really changed my perspective. Like the whole making a data-oriented compiler really changed my perspective on like the value of Rust for a compiler in particular. Especially when it comes to things like lifetimes and the borrow check or not. So for a little bit of other context, so my day job is I work at Zed. We make a code editor. It's all written in Rust. And the lifetimes of things in Zed are sort of all over the place. Like you're constantly like opening and closing UI elements and like, dragging things around, and like this tab's closing, and then like that tab maybe had a lingering reference to this other thing, which as soon as the last reference to that's gone, you need to like make sure it gets cleaned up, etc. Compiler is nothing like that. The compiler is like, first you do this phase, then 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 you're done. It's a little bit different if you have like a language server, but still the lifetimes are just not that complicated, and there aren't that many of them. It's nothing like a full graphical code editor. And I'm reminded of this conversation I had with Casey Muratori on my podcast, Software Unscripted. And this is like one of our most popular episodes of all time. We talked for like 3 hours about all sorts of stuff. And one of the points that he made that still sort of like sticks with me to this day, especially thinking about my early bad experiences with memory management, was he was like, basically, like, you don't need to make a pointer jungle. And if you make a pointer jungle, it's going to be really hard to manage your lifetimes, but you can just not make a pointer jungle. Like you can just think ahead of time about what are the different like times when my memory needs to be, active in this or that way. And oftentimes you can organize them in a much nicer way than the traditional, like, every time I need to put something on the heap, don't even think about it, just malloc it, and every time I need to get rid of it, don't even think about it, just free it.
Yeah.
I had never really thought of that. That was not something I'd been exposed to early on. I was taught, or book about like C and C++. That's like, yeah, that's what you do when you need to put it on the heap, malloc. When you need to get rid of it, free, or the C++, RAII equivalents of those.
Yeah.
And Rust, of course, very much encourages that paradigm. So I don't know what it would look like to try to apply that idea to like a giant graphical application like Zed, where you have just, at least like to my mind, there's just a ton of lifetimes and stuff like that. I don't really know what that would look like. I bet Casey, if he were here, would have some ideas, because obviously like games have a lot of those things in common, and that's mainly what he's worked on, which has led him to giving that advice. But I do know something about compilers and lifetimes now, and based on the experience that we've had, it's like, yeah, we really don't need that much help with lifetimes. That's not really a big selling point from Rust, especially not if you're doing the data-oriented design thing, because if you're always saying like, okay, I want to, and this is definitely something that we want, like I want to represent, instead of pointers, like actual memory addresses, which are, on a 64-bit system, those are 8 bytes. I actually want to represent pretty much all of my structures, not as like trees and pointers, but rather as like some big array or like an arena, which has indices into it that are like 4 bytes. Yeah. Well, as soon as you start doing that, it's like every time you want to dereference one of those, you need to know exactly which arena or which array you're going in and getting it out of. And that means that not only do you need to have the lifetime correct, because you need to have like actual access to that thing, but also you need to have the correct like backing store. And Rust just does not help you with that. Rust is like, yeah, it can give you like, okay, the lifetime in general, you can use a phantom data to like sort of make the lifetime go around. And if you want in like debug builds, you can make it so that it'll give you an error if you try to like, look up an index that was in the wrong thing, because you can store extra metadata in debug builds. But that thing that I just described is like, that's what you do in Zig anyway, if you wanted to have that level of safety. Like the strategy that you would use for getting that completely correct in Rust is the same strategy you would use to get it completely correct in Zig, which is to say like have some hidden debug information that tells you like, hey, this is the arena that, or the array that this ID was created with, and if I'm trying to look up into a different one, give me an error. Yeah. And of course, if you're able to get those correct, then like you're good. You got your memory management right, you got your lifetimes right, etc. So if there's not going to be compile time help with that anyway, or now I should say, I did actually experiment with the like, well, maybe I can at least get the Rust compiler to help me with the lifetimes aspect of this. And what I found was just that like, it just made my code a lot more complicated and a lot worse, and just didn't really feel like it was paying for itself, even like close to it at all. It was just like, yeah, now we have a bunch of lifetime annotations everywhere, and that wasn't even hard. Like it's not solving a main problem that I have. So that was one thing that was made us sort of be like, yeah, this is like the number one selling point of Rust is memory safety, and it feels like getting memory safety correct for this compiler is like not the thing that we need help with. The thing that we did need help with was feedback loop. So this was like the number one selling point against Rust, I guess, like after, getting a big Rust code base, was just like the compile times are long and the feedback loops are slow, like rebuild times for dev builds, just like, tens of seconds in a lot of cases, just like every single change just to rerun your tests to see if like, if they work. That was really painful. And then on top of that, I just don't think that situation is going to change anytime soon. Like I realize that like today, if you were to like benchmark Rust and Zig head to head, I don't think you would see like, oh, Zig has like a huge performance advantage, but it's like you have the x86 backend that's like about to land. It's like was like 99% of tests are passing, or maybe if it's like over 100 now. Like it has like like a bigger like test suite coverage than the LLVM backend. Whereas meanwhile Rust, like there's been a crane lift backend, which is crane lift is like an alternative to LLVM that is faster, but definitely not nearly as fast as going straight to machine code. And that was in the works when I started writing rock code in 2019. So like maybe that'll land, but I don't really know when. And that's just like one of that's the most promising change that I've seen like on the Rust roadmap. Whereas like Zig's roadmap has like, as soon as we're done with that, then we're going to have like an AR64 backend, which is relevant to us because most of the people working on Rust AR64. But also like even beyond that, there's the like incremental compilation stuff, and there's like with actual code gen incremental compilation, and like the linking stuff, and like hot code reloading. And I'm like, none of this. I have like I can't even imagine what year it would be that like Rust would get any of these things, just because of like the pace of development and the way that like the the committees work and stuff like that. It's just
Yeah.
I'm not saying that it couldn't happen in Rust. It's just that like I'm trying to build a compiler here. Like it doesn't really help me to say like, yeah, in like 2035, like, Rust gets those things. It's like we need to build this compiler right now, and we're really suffering with these build times. So even if like in this exact moment, I can't be like, oh, Zig is gonna, solve all of our performance problems right away. If we're starting on a brand new code base, it's like, well, now the compile times are low just because the number of lines of code is low. But I have way more confidence that if we build back up to, a very large compiler code base, that it won't be the same way by then that it has been in Rust. And that's like one of the hugest like selling points to me. And the last thing that was sort of really tipped the scales in Zig's favor is that if you look at the size of the ecosystems in the absolute, it's like obviously there's way more Rust code out there in the world, way more like bigger package ecosystem than there is in the Zig ecosystem. However, if you filter out like all the things that are irrelevant to us because we're never going to use them in this project, actually the relevant ones are bigger on the Zig side. So some examples of this are the way that the Zig compiler interacts with LLVM is the way that we would like to. That's like one of the many things that we had on our list to rewrite. For those who are aware, the way that Zig deals with LLVM is not by calling LLVM's APIs directly, but rather by generating LLVM bitcode, which has a sort of stable long-term interface, and then just handing that to whatever the latest version of LLVM is. This is a big deal because LLVM's API has breaking changes all the time, which are really, really painful to migrate. That's been like a huge time-consuming thing for us every time we want to upgrade LLVM. So the idea of like, oh, you can just generate the bitcode file, hand that to LLVM, and then it actually, they've done the backwards compatibility work for us. A, sounds really good, and B, that in the future, it can actually become a performance optimization because we can sort of like cache incrementally chunks of those bitcode files and like stitch them together at the end, instead of having to just like rebuild the whole thing from scratch every time. So that sounds really appealing. It's like, where are you going to find, some pure Rust code that just generates LLVM bitcode without a dependency on the LLVM API? It's like, that doesn't exist as far as I know. But in Zig, it's like, oh, there's actually a working production battle tested one in the Zig compiler, which is MIT licensed, that we can just use right away. And there's some other stuff like that. It's like literally the Zig compiler itself is like a very relevant part of the Zig ecosystem for us, because there's stuff where it's like, we want to do this exactly the same way Zig's compiler does. So like, oh, we can just take that directly, and there is no analog to that in the Rust ecosystem. Like nobody's doing it in that way that we want to be doing it. So putting all that together, it's sort of like, okay, so we have at least very good reason to believe that there's going to be much better compile times in the future. For the data-oriented design stuff, it's like Rust doesn't have an advantage, and actually like Zig's like the array list is actually quite appealing if you're doing data-oriented design. And again, there's no like direct comparison of that to Rust. There's sort of like analogs, but they don't quite have the nice ergonomics. And there's just like the general, Zig like comp time, and like the tooling is better, and like we want to be able to build with muscle libc so we can have a completely statically linked binary on Linux, and Zig makes that easier. And there's just this like long list of things where it's like our lives would be better in Zig, and the main selling points of Rust just don't apply to this project in the way that they might apply to other projects, which we didn't know at the outset. We've learned over the years. And finally, it's just like I and the other people who are working on the compiler, like back when I met with Andrew, I think it was just me and maybe one other person working on the rock compiler. And now it's like a whole bunch of people, and they all have like different backgrounds and stuff like that. And I just feel way more comfortable saying like, yeah, we're going to be able to actually do this. And like, I'm not scared of like, we're going to run into like these terrible, terrifying memory unsafety problems that are going to be a nightmare to debug. Maybe I'm wrong, and maybe we will. But especially given that like now I'm aware of those other tools like address sanitizer and Zig's like testing allocators and stuff like that, I just have a lot more confidence that we're going to be able to pull that off without the need for a borrow checker or anything like that.
That makes perfect sense. So with regards to the upcoming speedups in the Zig compiler, I did a stream. I think it was like 3 days ago by now, 4 days. But in any case, a few days ago, I did a stream with Matt Lug, who is a core team member, who specializes in the front-end part of the compiler. And I am also one of those people that has a ARM Mac. And so because of that, I was never able to experience the upcoming custom backends plus incremental compilation stuff. So in preparation for that stream, since we were going to try to fix a bug in the compiler and try also to show to people what it would take to implement a new built-in in Zig, just as an exercise, not a real one.
Sure.
he asked me to compile to get an x86 64 Linux machine, which I got like on DigitalOcean, and there I was able to try incremental compilation, and man, it was instant. Like the whole compiler instant. I was used to it taking like 5 minutes for the whole compiler to build. Well, maybe not five, but like at least two, at least a couple, and that was like a big, very big change.
Yeah, I mean, I'm hyped for that. Like, that sounds like exactly the experience we would like to get. And yeah, like I don't want to, give the impression that like I think Rust sucks or anything. Like I like Rust. There's a lot of things that I do like about it, and I'm happy using it at Zed. I don't think Zed should rewrite it in Zig. I think that would be a mistake. In the same way that I, based on the previous discussions we had in Rock, like it didn't make sense until the circumstances changed, and then it did make sense. But at the same time, I do think that if I could wave a magic wand, I've said this before on like my podcast and stuff, but like every single time there's like a state of Rust survey every year, I basically like every single box I check, I'm just like, don't care, make it faster. Like I'm like, I really like seriously, if I could pull a lever and make it so that all work on every aspect of Rust stops, but everybody prioritizes performance, like compiler performance is the top thing, I would pull that lever so hard and so fast it would make your head spin. Like, and yet, it just doesn't seem to be a priority the way that it is in Zig. Like when I talked to Andrew about it, he's like, yeah, like we want everything to feel like as instant as possible. Like, if you have like this giant code base, like ideally we still want to have like, sub-second compile times are like 1 to 2 seconds tops.
Mm-hmm.
Like even if you have like, whatever, like very large number of lines of code. And I just don't even see that sentiment from Rust. And I think, that's kind of reflected in like, what you see getting worked on and like, how much effort goes into, performance or other things, which I'm sad about, but I've tried to advocate for that perspective, and I don't think it'll change anytime soon. Although I wish it would.
Well, okay, Richard, allow me to do one rant. You don't have to agree with it. Actually, let me do the caveats. I'll try not to get too spicy. I will get a little bit spicy though. So Richard does not agree with what I'm about to say. This is entirely my own thing, but in the past, I've been snooping into what the Rust Foundation has been doing. And I've been saying multiple times that I don't exactly agree with everything that I've been doing, that they have been doing. I understand that the Z Foundation and Rust Foundation's very different beasts. They shouldn't be operating like us. We shouldn't be operating like them. But some things I feel like are not being done the right way. One thing that I did not appreciate was watching some of their at some point they had like a monthly recap of what the foundation was doing. And for a few times, their main point of it was like a 1-2 hour long video, and like I would sit and watch all of it. And the main point that they were raising is that the foundation was giving out cloud credits to core contributors so that they could build Rust using cloud infrastructure instead of their computers. And that to me means like you're solving the problem in the wrong way. I mean, sure, that can be a genuinely useful thing to do in the short term, but like that's not the way to go.
It's a Band-Aid, right?
Yeah, it's a Band-Aid.
Yeah, it's a Band-Aid, and obviously like it's a signal that like there's an what about all the Rust programmers who don't have access to that?
They just don't contribute, or they better not be poor.
Yeah. Well, and also just like, I mean, it's so obviously like that if that's valuable and if it's that like important to help the project go along, then like it's a really clear symptom that like, there's a lot of room for improvement there. And I think it would be one thing if, the official stance were like, yeah, like we've looked into these performance improvements and like we gave up. We just don't think it's possible to do these things. But that's not really the vibe that I get. The vibe that I get is that
I agree.
I hear a lot of, and this is not from like any official Rust sources or anything, but like when I've complained about in the past, a pet peeve of mine is that a common response is sort of like, oh yeah, but like in, this gigantic code base in this other language, it's even worse. It's like you have minute-long build time, so be thankful for what you have. And like to me, I'm like, well, it's hard for me to be thankful for what I have when I'm like, but over here in Zigland, I have the promise of like getting something way better than that. It's like it's not like I have to live like that, or at least I don't think that I will in like upcoming releases of Zig. But yeah, so that's been an ongoing frustration. But like, I mean, there's like I said, there's plenty of things to like about Rust. That's just not one of them.
Yeah. So I guess so. This was your experience getting more comfortable with the idea of doing lower level programming. What was your experience with the rest of the core team? Because I imagine that this idea. So you started with the compiler not being purely Rust, or rather the compiler, yes, but the project not purely Rust. You also had Zig in the standard library, so people uh, at least knew about Zig's existence. Maybe they, clicked by mistake. Core contributors that only wanted to focus on the compiler, by mistake they could have clicked on a Zig file, and so got a peek at what the syntax looks like. But you over time have built a group of people that obviously was comfortable writing in Rust. That's the language that they knew how to use best. How did it go in like the discussion in changing that? Because I'm imagining that a technological change, like you might have good reasons to change the language, but you don't want to change the people because you want to change the language, right? So everybody needs to be on board. How did that play out?
Honestly, that was super smooth. And I think in large part because everybody had already been exposed to Zig and had a positive experience with it. I think it would have been different if I was saying like, "Hey, trust me, let's rewrite in Zig," and everyone's like, "I've never written a line of Zig code. I've
Yeah.
never seen like how that might interact with our compiler." Because we already had this, large-ish successful code base. I mean, 10,000 lines is not that large, but it's far from trivial. And like everything about it had like gone well. I think that made a big difference. I also think that fortunately, like the most active contributors to the Rock compiler are people who are just like really interested in making Rock's compiler awesome. And so I think for them, I can't speak for them obviously, but the vibe that I remember from the meeting was sort of like, hey, if this is the like thing that's gonna like get us to where we want to go, let's go. Let's do it. Like let's go for it. And I think it was more about like, if we're laying out like here's where we are, here's where we need to go, here are the things that are in our way, this seems like the best strategy, and I think people just got excited about like this being like the best strategy. Separately, I do think also there's a little bit of an undercurrent of like feeling excited about like just trying a new thing where there's like a really good reason to do it. I think there's probably a lot of overlap between people who are like interested in using and working on a new programming language and also just being interested in like getting experience with a variety of different languages that, as long as they're compelling, like not just like, oh, here's a language that exists, let's go see what it's about. I'll spend a bunch of time on it. But like, here's a project where it's like, there's some really compelling, specific, concrete reasons to use this language and to like get, to experience that and to understand that language and how it's different from, what you've used before and how it's similar. I think that's appealing in its own right, as long as the payoff's something real and it's not something where you just feel like I'm just doing it. Then at the end, they're like, I don't know, that was a waste of time. Like, I think the fact that people are like, this is going to be valuable, and also I'm going to get to learn a lot from it, is definitely a selling point to people who are the type of person who is like interested in like a compiler for a new language.
I see. That's very interesting. So let me bring up like a specific example that I found particularly interesting when reading your gist, the one that ended up everywhere on social media. I think that in there you point. Oh yeah, we'll get to that in a moment. I think the Togglebeat had a question on it that I will ask you later.
Sure.
So I remember reading in there that you guys were using parser combinators to implement your parser. There is a big jump in going from parser combinators to multi-array list. Like, I guess my question is, I have experience. So by the way, I'm very happy that everybody is focused on the success of the project, and then you trust each other because there is a degree of trust that goes into making these decisions and following along with them. And like you can share ideas, like have ideas, exchanges, and make this work. But I like, if somebody were to go with memes and say, oh yeah, there's a bunch of functional programmers, how the hell do you get them from parser combinators to multi-array lists? So how was this in your exchanges, like in the Rock core team?
Well, so that was something where that was again an example of something that we'd independently decided we wanted to rewrite. And so I would say that like the reason I wrote the parser with parser combinators was just because like at that time that was what I knew how to write. I'd never written a parser in anything other than parser combinators before. So I was like, okay, I guess I'm gonna use what I know. And Bodil Stoka had written a blog post about here's how to do parser combinators in Rust. And me being pretty new to Rust, I was like, cool, let me take this blog post and like kind of adapt it to like do arena allocation. So we were already doing the like passing allocators around in Rust, even though that's like a Zig thing, like which was kind of funny because the Rust ecosystem doesn't really encourage that. But that was the style we're using anyway. And basically I was just like, yeah, let's just take the thing that I know and like get a parser done. Much later, we started talking about things like, okay, like, could this be simplified? Are there performance opportunities we're missing? Are there error tolerance opportunities that this style is making harder? And basically, the people who were spending more and more time on the parser, whereas I'd been spending less and less time proportionately, they were like, I think it would be a lot easier for us if we're like in like a traditional recursive descent. Like technically, parser combinators are a subset of recursive descent, but like a more like traditional imperative recursive descent parser. Something that I should mention is just like, although everybody who's like working on the compiler likes functional programming, I don't think there's anyone who's just like a purist about it and is like, oh, this is the only way to write code. This is the best thing. It's more like we like this style. We also like other styles, but we like this one too. And also like for different use cases, we might prefer different styles. So to me, like in my personal life, I tend to be like, the more I am interested in like fine tuning performance and the more hardcore I'm being about performance and the more performance critical the application is, the more I'm gravitating towards an imperative style just because that's how the hardware works. Conversely, the sort of less I care about performance and the more I'm just sort of like, yeah, I just really want to be able to write something that is easy for me to understand and debug, the more I gravitate towards a functional style because it makes it more natural to sort of isolate pieces and get be able to wrap my head around certain chunks and be like, oh, like in Rock, for example, we have purity inference where basically like in the type of the function, you can see, is this a pure function or does it do side effects? And you can just see that like, it's like a thin arrow versus thick arrow in the type of the function, thick arrow meaning it has side effects. And then basically I'm just like, cool, if this is a pure function, I'll be like, great. I don't have to worry about like so many things. I'm like, I can call this function every single time I call it with the same arguments. I am guaranteed to get the same answer no matter what. Like no possibility of anything else. And so all these things like fly out of my head that I don't have to think about anymore. So it's like gone. Like all these like burdens are lifted. However, as soon as I start like performance optimizing and like going really hardcore on that, I start being more like, yeah, like I'm thinking about, okay, the CPU is going to mutate this memory in this way. And so having my code be like, hey, go mutate this code, this like memory in this way. Like I'm more interested in that because otherwise I'm having to do this like, translation layer in my head between like, wait, what is this going to optimize to? Which of course there's still some of that, but all that is to say like, because the people who are working on Rock's compiler are already selecting for people who care a lot about compiler performance, we've already just got a lot of interest in like getting into this low level, imperative style of programming. Yeah. So it wasn't like a big tough sell. It was actually something that came from within of people being like, hey, given that we have these goals and we want to make the parser really error tolerant and really fast, etc., it feels like a better style than what Richard wrote because it was the only thing that he knew at the time to do a more traditional recursive descent parser.
Yeah, that makes total sense. By the way, that reminded me, if you guys still, you want to get you want to get used to the multi-array list style of doing things, and maybe you will find it super comfortable and get everything right first try. But if you don't find it super comfortable, here's one small suggestion. We have parser combinator libraries in the Zig ecosystem. So what you can do is use basically port your parser combinator parser in using the equivalent Zig libraries and use it as an oracle for fuzzing so that you can implement your multi-array list, indices and everything imperative, blah, blah, blah. But then you can at least use like what you're comfortable with, you keep using as an oracle to make sure that your tests are correct and that your implementation respects what you expect.
Gotcha. I think it's unlikely that we would want to port the existing Rust code over, to be honest. I think like, so another thing that we decided to do was to like fuzz from the get-go, like fuzz as early as possible, start fuzzing, because in the Rust compiler, we did not start fuzzing until very late in the game. And two things that we discovered are, one, as you might expect, fuzzing turns up a lot of bugs. That's really good for like correctness and figuring out how things work. No surprise there. But the other thing that we learned is that, especially with this project, because you get these sort of wild combinatorics of like, oh, like if you do this thing in conjunction with this feature and this feature and this feature, then it triggers a bug. But if you subtract one of those, then everything's fine. Because of that, like the further along that we got, the more complicated the compiler was, where we tried to apply fuzzing, the less useful it was, because you get this error and it's like, cool, this error only comes up when these like, several different features interact. Which one of them is the cause of the bug? Whereas, once we have the fuzzing in place and it's like, we've got this very small, not featureful at all compiler is working and fuzzed. Every time we introduce a new feature, if that trips up the fuzzer, it's like, oh, well, what's the thing that's causing it? It's the thing I just did, because previously we had, a clean bill of health when it came to fuzzing. And now after introducing this pull request, we don't. So that, tells us like, oh, okay, here is where the problem came from. So yeah, definitely looking forward to that. One of the things that I don't know actually if this is already like in progress or not. One of the things we talked about was using like fuzzing to and from the formatter, because like Zig, we also have a built-in code formatter as a nice way to verify whether things are being parsed correctly. So the idea is like you parse the thing, you format it, you parse the thing that the formatter spit out, and that should be stable. In other words, it should give you out exactly the same thing as what the formatter first put out. That on its own can just catch a bunch of stuff. And then not only do we not need an Oracle, because that's sort of, giving us a lot of confidence that like the parser is at least like not crashing and producing stable formatting, but it's a test we want anyway for the formatter. So it's sort of like kind of a, gives us a twofer, but but that is good to know that Zig does have parser combinators if we ever want to go back to that, but I don't think we do.
Yeah, that's fair. To be honest, I was suggesting it in case that it was useful. I guess the idea of you keep doing what was comfortable, but you only keep it as an oracle for testing is a general valid strategy. But that might not apply in this case, but it's good to know. Although specifically to parser combinators, there is a CLI, a command line argument parsing library called zigclap. That is inspired by clap in Rust. That one uses parser combinators. And I remember in the past, Andrew like looking at me, wiring it up and like looking at me and saying, why are you just not writing parsing code for your CLI arguments? And me saying, I don't know, I'm lazy, blah, blah, blah. Fast forward a while, and every time that something changes, like Zig changes enough, and then something breaks in the dependency, I get annoyed because now it's like a recursive, it's like turtles all the way down, right? It's parser combinators and metaprogramming all the way down. And so now I start appreciating just writing my own damn parsers. So now I do the same thing that Andrew does. You just sit down and you write it. So anyway.
Yeah. Yeah. Well, so like on that subject of like rewrites and like going from, one code base to another, I don't know how much this works with like upgrading between versions, but one of the other things that we talked about is that compared to the last time, like, around the Handmade Seattle era that we talked about, like, oh, should we rewrite the compiler from Rust to Zig? A thing that has changed is that now we have large language models, which obviously you cannot just be like, hey, Claude, rewrite the whole code base from, Rust to Zig, done, but what you can do is you can be like, hey, here's this chunk of Rust code. Here's the like Zig file, that I'm like converting it to. Here's what the old Rust code looked like. Can you just convert that one chunk? And it's not going to get it right. But the idea is that like having a large language model do something pretty like a mechanical conversion, which I can then review and fix, could very well be a lot faster than my just like doing every single, okay, this becomes this becomes this becomes this. We don't know to what extent that will or not be valuable. Like, maybe it will, maybe it won't. My guess is that it's like some amount of valuable, but not a, like perfect solution. Also, in a lot of cases, like we want to rewrite some of these things because like we want to change how they work. But I would imagine that like there's some percentage of the rewrite that goes a lot faster because we have access to this tool that we didn't have access to, several years ago.
Understood. So how was your experience with fuzzing? So you mentioned that you started fuzzing a little bit late, but how was your experience with the tooling? Did everything work fairly easily? Or did you have to do certain things like kind of on your own?
You mean on the Rust side?
Yeah, on the Rust side.
Got it. So I actually didn't work directly on that. One of the things that's like funny about the project is like, so between when it started and now, like the major thing that's changed for me is I had a kid. And so now my free time to work on Rock is very diminished. And so I tend to prioritize things that are sort of like, I don't know, more like high level design type stuff. And so I'm spending proportionately a lot less time in the code than I used to the point where actually, so I was out of town last week on top of everything else. And also like, this was when like we decided to do the rewrite. So I actually have not written a line of the rewrite yet. It's been all other people, which is funny to me because, going all the way back to 2019, it was like there was a time, quite a while, where the entire code base is written by me. And now the new compiler, so far, none of it's written by me. That's got to change. Like once I get some like stuff off my plate, or burn through my to-do list of other things to do.
Yeah.
But the fuzzing in Rust is an example of like one of the things where I actually had nothing to do with it. Like completely other people on the team like worked on it. So I'm aware of like the things that people talked about, but I don't actually have hands-on experience in like setting it up or like using it.
I see.
I do know that like some of the things that people ran into was like, it did take a while to get set up. I don't know the exact reasons for that, but I think it had more to do with just like, I don't know, like building up the infrastructure that's like specific to our project as opposed to like I think there was a pretty basic template you could use to just be like, get some sort of fuzzing going, but then like setting up the stuff that was specific to our compiler, I think was what took longer. But others like Brendan and Josh could talk about that more specifically than I could.
Okay, that's cool. You know what? Maybe I'll find Brendan and whoever else was involved, and we can have an episode dedicated to fuzzing in the future. By the way, I was asking because I've been doing some fuzzing stuff recently. Well, a while ago with Zig, and in fact, I believe that you guys are using my beautiful Zig AFL kit to integrate with AFL more easily. But in any case, I just find it an interesting thing to talk about. So I have one last question for you. Before I would say we can call it a day, if chat has any questions that you want to ask Richard, this is the time to type them in chat. I also see that there's a lot of Rock contributors in chat. Like I see Go G Whirl, who's saying that they're writing the Rock parser in Zig, and they ended up using MATLAB's idea to create a type-safe API over row SOA indices. Yeah. You're going all the way. That's awesome. It's really exciting to see this, like these ideas being approached by people who, were not originally part of the Z community, who came up with them, and like see how that goes for everybody else. Because, maybe something that works for you and that you think should work for other people, turns out that it does not work for everybody else. So yeah, that's cool. So I guess my question for you is, if you could, what would you say to your old self to give yourself like the confidence that no, you can do systems programming, right? Because your perspective of saying, yeah, I don't see myself as a systems programmer, it's very common. That applied also to me too. For the majority, well, by now not anymore, but like for a good chunk of my professional life, my thinking was, oh, you know what? I learned web development. That is enough annoying ecosystem stuff to learn. There is no way I'm going to learn C and C++ as well and all the weird bullshit that's down there. So this is going to be what I do for now. So how do you convince more people that systems programming is actually, Zig style, not necessarily the Rust style, but like Zig's more dangerous style is actually something that is approachable and you don't have to be a wizard to approach it.
Yeah, okay, so 3 things come to mind that I think would have, well, first of all, in 2019, I don't know if Zig was far enough along for me to like tell my past self, hey, use 2019 Zig, you're gonna have a great experience.
Yeah.
But 2025 is a different story. So I would say 3 things come to mind as like things that I guess I wish I had known or I wish someone had told me. One is, setting aside Zig in particular, just broadly, like there are tools that you're not aware of that can make this easier. Like Zig is one of those tools, and also Zig has a bunch of tools within it. Like I'd never heard of address sanitizer, for example. So like you don't have to be stumbling around in the dark. I also didn't even know stuff like when I got a segmentation fault, I didn't know what to do. I didn't know like, oh, well, like bust out, GDB or some debugger and like set a breakpoint and then go in, you can get a backtrace. I was just like, yeah, I guess like these are the words that I have to work with. It says segmentation fault when I sometimes, when I get to this part in the program, sometimes not. I don't know. So like knowing that there exists tooling to like get you unstuck when you run into that would have been helpful, just to know that it's like, okay, even if this is painful, it doesn't have to be scary. Like, this is going to be a total nightmare to track down, which even with those tools, it's not like it's necessarily trivial, but that would have made it a lot better. Second thing I wish I'd known is there's an architecture that you can adopt that makes a lot of these problems, a lot less serious or go away. Like as far as I knew, it was like malloc and free everything is the only way to do things. As soon as the heap is involved, I just like wasn't aware of the other techniques where you could possibly like reduce the error proneness of these things. And then I think the last thing would just be, I don't know how else to put this other than just like some sort of someone saying to me like, hey, like a lot of people don't know how to do this the right way. And so like when you think about the stereotypes of like, oh yeah, this code like that is memory unsafe leads to all these CVEs and like all these problems. It's like, that's because a lot of people who are writing that code are doing it wrong. That's not going to automatically apply to you just because you're working in that same, at that same low level. Like there's also, as a good example of this, it's like, there's a ton of C code running on tons and tons of little computers in your car. Like people can write code that's that low level that does not crash your car. In fact, I would venture to guess that I am more likely to see a bug in my car from some sort of like TypeScript code that's running the UI in the dashboard than I am in like, that's controlling some servo somewhere in the car that's written in C with no memory safety whatsoever. Because they know better techniques. They know about how to architect for this style of coding better. They're using, address sanitizer and then some and fuzzing and all the other stuff. And you might make the point like, the level of coding that they are using, or at the extreme end you have like NASA, is really really ridiculous, and you don't want to have to code like that. It's like, yeah, I mean, fair enough, but the point is that it's achievable to write code that is not seg faulting all the time, in these low level languages, if you know the techniques, if you have the right tools. And so my past self assessment of like what it means to write these languages as like, oh, you just have to have this like wizard skill set is not true. Like really, like if you know the tools and you know the techniques, it doesn't have to be scary, and it's not just like something you're born with or not. It's like something that you can learn. That's what I think my past self was missing in terms of perspective.
Thank you. That makes perfect sense. So then last question that Toggle asked me to ask you, and I might not phrase it exactly as he phrased it originally, so apologies, Toggle, if I'm gonna twist your question a little bit. But so you wrote the gist that ended up on Hacker News, but you said right now that you did not intend for that to happen. So I remember seeing it. I remember seeing it. That I was watching Toggle's stream, and somebody in chat had linked it to him, and I was asking, wait, where did you guys get this? And so since I hadn't seen like you publish it yourself publicly, I assumed that might have been the case. So I ended up not reposting it anywhere. But I guess the idea is, how much of what you do, what would you have phrased it differently if you had designed it to go on Hacker News, for example? Did you get like, I don't know, did you get people slam you in DMs because you were going for a non-memory safe programming language? How was your experience there socially?
That's a good question. So so the background here is just that like today is Monday. Not last Friday, but the Friday before that was when the Rock contributors, we got together and we were having a chat about like all the stuff we had upcoming. We decided let's go with a Zig rewrite. And so everybody got really excited and went back to Rock Zulip and starting all these channels about like, okay, let's talk about this aspect of the Zig compiler, that aspect of the Zig compiler. And I hadn't really like communicated anything outside of that group, and so a lot of people on Zulip were like, "The
What's
what
going
now?
on?"
The Zig compiler? What is this?" And so I started obviously getting questions about like, "Hey, I'm inferring from context that the compiler is being rewritten in Zig. Like, why?" And so I was like, "Okay, I need to write something up just for like Rock Zulip." So I wrote this gist. I think at the top of it, I was like, hey, this might turn into a blog post or something someday, but like, for right now, I just want to like answer people's questions. I kind of explain, just give them the backstory on like why we're making this change. So I just posted it in Zulip. Obviously, somebody on Zulip posted it on Hacker News, and one thing led to another. I think the main things I would have done differently is that I would have spent more time, I think like talking about some of the background of like basically the stuff that we talked about at the beginning here of like, like I'm not saying that like Rust sucks or anything. It's just like here are the reasons that we're doing this. And I think I did talk about the like why memory safety hasn't been as useful in to us as like it has in other projects like Zed. Uh, but but I guess the reaction was not really what I expected. So first of all, I heard about this on Hacker News. I was like, oh no, I can only imagine what the comments are like. But
Yeah.
actually, I mean, the top voted comment, at least like the last time I checked the thread, was actually someone saying like, this is one of the few explanations I've seen of a rewrite away from Rust that made sense to me. So I guess I did a good enough job explaining like, you know, our motivation and why in our particular circumstance that seemed like the right choice. So that was nice to see. Honestly, most of the thread in Hacker News, it seemed like kind of devolved into like things unrelated to Rock, just like people arguing about like generic, you know, Rust versus X versus Y or whatever. So I didn't think that was you know, out of character for Hacker News, but it also was. I mean, like, you know, whenever something that you write ends up on Hacker News, like on the front page, then there's always a you know, like you know, you shouldn't read the comments, but you also kind of want to read the comments. And then what's annoying is when somebody like misunderstood what you wrote or is like attacking you despite understanding what you wrote or like misrepresenting what you wrote. When they're just arguing about like, you know, tangential things, then I'm kind of like, okay, whatever, that's fine. It doesn't really bother me that much. So I think all things considered, it could have gone a lot worse. It's like if I had written something up more formally intended to potentially be consumed by that audience, I think I would have felt better about it going in. But honestly, I can't really complain about the outcome because it went about as well as I could have hoped, you know, under the circumstances.
Yeah, it seems so too. Like, I agree that there was like overall like not a overly negative reception. Although I did feel disappointed, honestly, that although not surprised, disappointed but not surprised, that Hacker News went really deep into this feature versus that feature, that thing versus that other thing, and nobody really appreciates the human side of it, which actually is probably the most important part. Like, how do you build a community? The community, it has preferences, and that, like, all of this stuff has to be in harmony with whatever technological choice you make. And so Hacker News wasn't really appreciating the nuance there, I guess.
Yeah, I mean, I think I had like one sentence about that in the post where I'm like, we're really excited about this, but that's really, really underselling it. Like,
Mhm.
it was something like the flurry of activity on Zulip, like after we made this decision, was just like really unprecedented, especially around like compiler development topics, where like one person was like, he shared a screenshot where he was like, I just checked this in the morning, now it's the evening, there's like 1,000 unread messages. Like, how am I going to keep up with all this? Because everybody's just like really, really hype about
Yeah.
this. And yeah, I do think that's something that's easy to get lost. And like, you know, I was mainly focusing on the like, hey, given that we made this decision, like here's the reason why. But yeah, I think a blog post like talking about that like as like a really just exciting thing that makes a lot of difference in terms of like how the project's going to go would have probably been a good thing to include.
Nice. Well, I hope that everything goes well for you guys in the ride. I hope that you have a good time. I hope that if you depend on any of my code, that it doesn't break too hard. If it does, I apologize. And yeah, I'm looking forward to see where this goes. And also, you know what? If you ever decide to move away from Zig, you know what? I think all I hope is that you guys keep the same ideas, like optimizing with struct of array versus array of structs. And at that point, if there's another language that does it better, who cares? I think that's what matters. Because at the end of the day, as a user, what drives me nuts is slow tooling. That makes me go insane. And I care about that way more than the language. I went to a conference dedicated to web tooling. It was called SquiggleConf. So it was perfect. And squiggle is in, the red squiggle that the tooling shows you when, for example, linters or LSPs when you write something wrong. And I presented there my HTML language server that I believe I told you about when we were in New York. So I was still writing it, right?
I remember this.
Yeah, I completed it.
Yeah.
It's on the Visual Studio Marketplace. People can use it. And I went on stage and I remember saying, for the love of God, please, everybody, do not write tooling in JavaScript. And there were some people who were not on board with that idea in the audience. So I feel like it needs to be said. tuning for developers needs to be fast. It's like it's a death by 1,000 cuts if it's slow and bloated.
And I mean, one last thought on that topic is like, if I'm using like a code editor or whatever, there's a frame rate, right? Like at 60, 90, 120 frames per second. And as long as you're under the frame budget and you're not dropping frames and I'm getting what feels to me like instant feedback, like I don't really care what you write it in. If it's like, if you tell me that like, hey, I got the responsiveness of this thing down from like 10 milliseconds to 1 millisecond, I'm probably not going to notice because like I'm a human and my reaction time's not that fast.
Yeah.
But if you tell me you got it down from 10 seconds to 1 second, I'm like, wow, this is a night and day total difference. So like, there are some domains where it's like, yeah, I'm not really going to notice you writing it that fast. Developer tooling is just not one of those domains. It's one of those domains where like, especially once your code base gets, past a certain size, it's like, it's always too slow. Like it always could be noticeably faster.
Yeah.
And so that's exactly why I'm saying let's never self-host the compiler, is that like, I just don't think this is one of those domains where it's the best choice if you really, really care about user experience to use anything other than a language that gives you, the highest level that you possibly can of ability to optimize your performance, because we just need it.
Yeah. That makes perfect sense. Somebody in chat is asking, what's the time frame for their rewrite or the timeline? Well, they started already, right?
Yeah, we started it last week, so it'll probably be done this week. No, I mean, like the timeline for starting is just like, yeah, we dove in and just started doing it right away. And like I said, everybody's super hype about it. We've been talking about like strategically how to go about it. Like we kind of want to do the long thin slice, like get everything working end to end. Like even if it's just like the joke was like, we'll just have the language only support strings for now, but strings work all the way end to end. And then we can add more and more features. Cause like I said, we want to get the fuzzing set up from the get go, and make sure all different stages of the pipeline in the new design are, working together and talking to each other appropriately. But yeah, like I said, also, if anyone wants to get involved in any stage of that and you're just like, hey, I'd like to work on a Zig compiler, just like hit me up. We'd love to have new contributors. We're always happy to onboard people. But yeah, as far as like timeline of like when it's done, it's like it's done when it's done. We're just going to find out how long it takes because, like I said, these are all features that we want to add anyway. These are all changes that we wanted to make to the compiler prior to the 0.1 release, which is our next major milestone. And so however long it takes us to get there, that's how long it takes.
That makes perfect sense. Somebody is joking that only supporting strings worked really well for Tcl, so my work was nice. Man, that was a great chat. Thank you, Richard, for taking the time to hop on the stream and do an episode with me. This was a really interesting thing to learn about also from the perspective of somebody involved with the Zig project. That was great. Is there anything else?
Thanks for having me.
Thank you. Is there anything else that you want to add before we call it a day and end the stream?
Yeah, I mean, check out Rock, check out Zed. Also, very nice code editor, even though it's not written in Zig. It's still very high quality, and I love it. And that's why I work there, because I used the editor first, and I decided to join the company because I wanted to work on it. Yeah, I think that's it.
That's it. I'll add one last thing for you then. I saw that you have been streaming occasionally on Twitch. People, if you check out the title of this stream, you can see that I'm tagging Richard. That's his Twitch account. I also gave him a shout out in chat. Go follow his channel if you want to see him work on, I believe you have been streaming Zed, but maybe you will also occasionally stream Rock in the future?
We'll see. I have no concrete plans, but you never know.
Yeah.
Also, I guess I should have mentioned I have a podcast called Software Unscripted, which Loris has been on a couple times. And we talk about all sorts of programming topics. We kind of go deep.
Yeah, let me find the link to Software Unscripted. I'm going to put it in chat.
We have a YouTube channel as well as a like the recordings are on YouTube, but also on like various.
Yeah. What do you want to link? What do you want me
media.
to link? I have the YouTube channel. Is that good?
Sure. Yeah, but also if you're on Spotify or Apple Music or whatever else, that we have it broadcasting to all of those via audio as well.
Perfect. Okay. Thank you for your time, Richard. And I think this is it. Thank you everybody for stopping by. I'll see you on the next Zig Showtime episode. And we haven't scheduled it yet, but probably it's going to be a very interesting one because I have it already lined up and it's going to be super good. So thank you all and see you next time.
This is how we